Hello everyone, my name is Daniel Munzimana. Today we are going to talk about the interview questions and the answer, which explain the use of linked list to implement both stack and queue, including their time complexity. So the first question that we have is explain how you would use a linked list internally to implement a stack. Make sure to explain the way you would use the linked list and the time complexity associated with each of the following operations. First is push, pop, get, top is empty. So the answer for it. Implement a stack using linked list. We use, as we know, stack, we use LIFO behavior, which is last in, first out. And the structure of it, we use single linked list and perform all operation at the head of the list. And we are going to see the operations of it. So here we have a push, which is the add to the top, add something to the top, add new node to the head, and time complexity is big order 1, which is constant time. And also we are going to see pop, which is remove item from the top and remove the node from the head, as it's explained. Time complexity is big order 1. And also we are going to see get top. Pick at the top is to pick something from the top. Return the data in the head without removing it. Just to return the data from the top without removing it. And also time complexity is big order 1. And IsEmpty operation is to check if head is null, as understandable. And time complexity is big order 1. We are going to look on the second question, which explain how you would explain how you would use linked list internally to implement a queue. Make sure to explain the ways you would use to linked list and the time complexity associated with each of the following operations, which is, as we know, the operation of queue is unqueue, dequeue, size, and IsEmpty. So the answer, implement a queue using linked list, we will see. And as we know, queue use FIFO behavior, which is first in, first out. And also the structure of it is it maintain both head and tail. They have a head and tail. So and those have pointers, or you can say link, and also add the tail, remove from the top, from the head, to add tail and remove from the head. And also operations, there is an queue, add to back, add a node at the tail is to add a node at the tail. And also there is the time complexity is big order 1. And also the size is to maintain, count as element are added or removed or iterate through the list. And also we are going to see the dequeue is remove from front. And time complexity, you can remove node from the head. Time complexity is big order 1. And also the time complexity of the size is big order 1 if tracked, and big order n if is iterated. And as we've seen, the time used to maintain the count element or add from the add or remove to iterate. And IsEmpty is to check if the head is null. Time complexity is big order 1. Thank you for watching.